Hello, aspiring electronic engineering graduates and tech enthusiasts. Welcome to our channel. If you're preparing for technical interviews in the field of electronic engineering, you're in the right place. In this video, we'll cover the top 33 technical interview questions and provide you with comprehensive answers to help you stand out during those crucial interviews. So, let's dive into the world of electronics and pave the way to your dream job. 1. What is Ohm's law? Ohm's law states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points, with the proportionality constant being the resistance. 2. Explain the difference between analog and digital signals. Analog signals are continuous waveforms that represent data using varying voltage levels, while digital signals are discrete and represent data using binary code, zeros and ones. 3. What is the purpose of a diode in a circuit? A diode allows current to flow in one direction only, acting as a one-way valve for electrical current. 4. Describe the working principle of a transistor. Transistors are semiconductor devices that amplify or switch electronic signals and work based on the controlled flow of electrons or holes. Hey there! If you're enjoying my content and want to see more, please consider hitting that subscribe button. It's completely free and it helps me out a lot. 5. What is the function of a capacitor in an electronic circuit? Capacitors store and release electrical energy in the form of an electric field, providing filtering, smoothing, and energy storage functions in a circuit. 6. How does a microcontroller differ from a microprocessor? Microcontrollers are integrated circuits that contain a CPU, memory, and peripherals in a single chip, designed for specific tasks and embedded systems, while microprocessors are general-purpose CPUs used in computers. 7. Explain the concept of the Nyquist-Shannon sampling theorem. The Nyquist-Shannon sampling theorem states that for accurate digital representation, a continuous signal must be sampled at a rate of at least twice the highest frequency component of the signal. 8. What is the significance of Kirchhoff's laws in circuit analysis? Kirchhoff's laws, Kirchhoff's current law and Kirchhoff's voltage law, are fundamental in circuit analysis, allowing the calculation of currents and voltages in complex circuits. 9. What are common types of memory used in microcontrollers? Common types of memory in microcontrollers include ROM, read-only memory, for program storage, and RAM, random access memory, for temporary data storage. 10. Describe the working principle of a logic gate. Logic gates are electronic devices that perform basic Boolean operations, AND, OR, NOT, etc., and process binary inputs to produce binary outputs based on specific logic rules. 11. What is the difference between a BJT, bipolar junction transistor, and an FET, field effect transistor? BJTs use both electrons and holes for conduction, while FETs rely on voltage-controlled channels for conduction, making FETs more suitable for high-frequency applications. 12. Explain the concept of an operational amplifier, op-amp. Op-amps are versatile, high-gain, differential amplifiers commonly used in electronic circuits for signal processing, amplification, filtering, and mathematical operations. 13. What is the significance of the cutoff frequency in filters? The cutoff frequency is the point at which the filter attenuates the input signal by half its maximum value and plays a critical role in determining the filter's bandwidth and roll-off characteristics. 14. What is the purpose of a Schmitt trigger in digital circuits? A Schmitt trigger is used to convert an analog input signal into a digital output, providing hysteresis to reduce noise sensitivity and ensuring a clean, well-defined transition. 15. What are flip-flops, and what are their applications in digital circuits? Flip-flops are sequential logic circuits used to store one bit of data. They are crucial elements in digital memory, counters, shift registers, and clock synchronization. 16. How does an ADC, analog to digital converter, work? ADCs convert continuous analog signals into discrete digital values, mapping the input voltage to a specific binary representation for digital processing. 17. Describe the concept of a voltage regulator. Voltage regulators maintain a stable output voltage regardless of variations in the input voltage and load current, providing reliable power supply to electronic circuits. 18. What is the function of a comparator in electronic circuits? Comparators compare two analog input voltages and produce a digital output based on their relative magnitudes, used in decision-making applications and waveform shaping. 19. Explain the working principle of a multiplexer, MUX. A multiplexer is a digital circuit that selects and routes one of many input signals to a single output based on control signals, enabling data transmission and selection. 20. What is the difference between half-duplex and full-duplex communication? Half-duplex communication allows data transmission in both directions, but not simultaneously, while full-duplex communication enables simultaneous two-way data transmission. 21. Describe the purpose of a decoupling capacitor in a power supply circuit. Decoupling capacitors are used to filter out high-frequency noise and provide a stable and smooth DC voltage supply to sensitive components in a power supply circuit. 22. What is the concept of gain and bandwidth in operational amplifiers? Gain is the amplification factor of an op-amp, while bandwidth refers to the range of frequencies over which the op-amp maintains a specified gain value. 23. How does a multiplexer, MUX, differ from a demultiplexer, DEMUX? A multiplexer routes multiple input signals to a single output, while a demultiplexer routes a single input signal to one of several outputs based on control signals. 24. Describe the working principle of a phase-locked loop, PLL. A PLL is a feedback control system that synchronizes the output frequency of an oscillator to the phase and frequency of an input signal, used for frequency synthesis and clock recovery. 25. What are the primary advantages of using microcontrollers in embedded systems? Microcontrollers offer compactness, cost-effectiveness, low power consumption, and integration of CPU, memory, and peripherals, making them ideal for embedded systems. 26. What is the significance of a pull-up or pull-down resistor in digital circuits? Pull-up and pull-down resistors ensure a defined logic level at a specific node in a digital circuit, preventing undefined states and reducing power consumption. 27. Describe the concept of noise in electronic circuits. Noise refers to unwanted electrical disturbances or fluctuations that can interfere with signal integrity and impact the accuracy and performance of electronic devices. 28. Explain the role of a watchdog timer in microcontroller applications. A watchdog timer is a hardware-based counter that resets a microcontroller if it detects a malfunction or a software deadlock, enhancing system reliability. 29. What is the purpose of a buffer in an electronic circuit? Buffers isolate circuits with different voltage levels or impedances, preventing signal distortion and ensuring efficient signal transmission. 30. How do you calculate the bandwidth of a digital communication system? The bandwidth of a digital communication system depends on the data rate and the modulation scheme used to transmit data, determining the range of frequencies required for signal transmission. 31. Describe the working principle of a voltage-controlled oscillator, VCO. A VCO is an oscillator whose output frequency is determined by an input voltage, making it ideal for frequency modulation and phase-locked loop applications. 32. What are the different types of flip-flops, and how do they differ in their operations? The common types of flip-flops are D flip-flop, JK flip-flop, RS flip-flop, and T flip-flop, each having distinct clocking and input characteristics for various applications. 33. Explain the function of a sample and hold circuit in analog to digital conversion. A sample and hold circuit captures and stores an analog input voltage at a specific moment, holding the value constant for the ADC to convert it into a digital representation. There you have it, the top 44 technical interview questions and answers for electronic engineering graduates. We hope this comprehensive guide has provided you with valuable insights and boosted your confidence for your upcoming interviews. Remember, preparation and practice are key to acing any interview. If you found this video helpful, don't forget to give it a thumbs up and subscribe. Thank you.